Okay, so I'm going to do a very quick overview of what we talked about in class today for those of you who missed. I would still encourage you to get the notes from a student who was in class because that's going to give you a better understanding of the material. But I wanted to give you something so that when you come to class tomorrow that you are not falling behind. Okay, so we looked at two things. We talked about graphing the sine function and then graphing the cosine function. All right, so let's talk about the sine function first. All right, so what we did in class was we looked at a table of values, like what you would do, say, in junior high when you were trying to graph something. Okay, so we came up with a table of values. I asked the students to use for the x values. Remember, you can choose anything you want, but I suggested that we use 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we're later going to refer to these as our 5 key points. So then we talked about what happens when you plug these values into the sine function. So these are angles, and so when you take the sine of a particular angle, for example, sine of pi over 2, okay, this is something like we saw on our test where we had to find the value that went with sine pi over 2. If you remember that since the angle is actually lying on the x and y axis, so our 90 degrees or our pi over 2 is here, our technique is to pick a point. You can choose any point that you want on the terminal side of the angle. So maybe you pick the point 0, 3. So then you know that A is 0, B is 3, and the R value is also going to be 3 because remember that the R is the distance from the 0, 0 point to the point that you chose. And then remember that your formula for sine is B over R. So for this particular angle, we would do 3 over 3, which would equal 1. And so then we would go back into our table of values and put a 1 for that y value. And so we could do that for all 5 of these points. To make things easier, I'm just going to go ahead and fill them in. Okay, and once we had those 5 points done in class, then we went to our paper and we drew a graph. So you can see that on the left-hand side of the screen. We would go through and we plot the 5 points. So like 0, 0 is our first point. We would have put a dot here. And then above the pi over 2, we would go up to 1 and place a dot. The third point would be pi and 0. So that would be here. 3 pi over 2, negative 1. And finally 2 pi 0. And we would connect those points, making a graph of the sine function. We talked about in class that this graph goes on forever in both directions, so it's not a complete graph that you're looking at right here, it's just a part of the graph. All right, we also talked about in class that we should know that what is called the period of the graph, and the period of the sine graph is 2 pi. And what that means is if you start at 0 and you start tracing the graph, that you're going to trace all the way till you get to 2 pi before you start to repeat yourself. So if I go further than 2 pi, then I'm going to be coming up like this, and this part is a duplication of this part. So if we want only new stuff, we stop at 2 pi. Okay, so the period is 2 pi. The amplitude of the graph is going to be 1. Amplitude refers to the height of the graph. How high and how low does it go? From the 0, 0 line. So from the x-axis, the highest point is at 1, the lowest point is at negative 1. Amplitude is always positive. It's a measure of distance. It would be 1. All right, and then we also made a point of saying that if these 5 points over here are going to be our 5 key points, that we have x-intercepts on the sine graph at the first point, the third point, and the 5th points. And the reason that I'm not more specific than that is that these actual values will change, but the pattern won't. So if you can remember that your x-intercepts are at first, third, and fifth for the points, then that makes it easier for you to draw the graphs that we're going to get to next. Okay, so then we started talking about transformations, which we looked at a little bit last semester in algebra with an algebra function. All right, so the first thing that I showed the class was that if you put a negative in front of the sine function, that it flips the graph over the x-axis. So if you think about your normal sine graph that we looked at here, the graph leaves 0 and goes up to 1. So I'm going to just kind of sketch the regular sine graph. So leaving 0 and going up to 1, coming down, going around, and up. So the red graph that I just drew is the regular sine function. And so if I put a negative in front of it, it just flips the graph down or up and makes a reflection over the x-axis. All right, so you want to keep that in mind, that putting a negative reflects over the x-axis. All right, from there we talked about changing the amplitude. So this function is going to be the graph of y is equal to 3 sine x. So we talked about putting a number in front of the function and how that caused the amplitude to stretch. So again, remember that your normal sine graph just goes up to 1 and comes back down, and then goes down to -1 and comes back up. And so now we have stretched that because of this 3. The graph goes all the way up to 3 and all the way down to -3. Okay, notice that your x-intercepts stay the same. So first, third, and fifth points don't change, but your amplitude does. Okay, so we can have that kind of change. And then we also can have this kind of change where the graph is y is equal to sine 3x. So here you're looking at having a number inside the parentheses that you're taking the sign of with the x. This is going to cause a change in the period, and this is going to be definitely the more difficult transformation. You're going to have to do some work with this type. All right, so what we're going to do is we're going to make an inequality, and we're going to put this 3x in between 2 pi on the right-hand side and 0 on the left-hand side. Now, the reason that I'm doing that is because if I go back to my original graph for my sine function, my original graph starts at 0 and ends at 2 pi. When I change the period, I'm either going to compress the graph from side to side, which will make it smaller, or I'm going to stretch it out from side to side, which will make it longer. But either way, the 0 to 2 pi is going to change. And so what we're doing when we set up this inequality is that we are starting with our starting point. This is our beginning point of the graph. And this is the ending point of the original graph. And then we're going to change it. So our goal in making this inequality is to get x by itself in the middle of the inequality. So in order to do that, I'm going to have to divide this middle part by 3. And if I do that on one part, I'm going to do it on all 3. All right, so let's look at what we've got. So I've got 0 over 3 is still 0. 3x over 3, the 3's cancel, leaving me just an x. And then I have a 2 pi over 3. So what I now have is a new starting point and a new ending point. So on my graph, I'm going to go ahead and mark off the 0 as my new starting point, and I'm going to mark off 2 pi over 3 as my new ending point. Now remember that the graph is based on 5 key functions. So we have 3 tick marks that sit equally spaced in the middle of the graph. Now, I need to label those tick marks. I need to know what the spacing is that's being used from one tick mark to the next. So in order to figure that out, I'm going to take the distance from start to finish. Okay, so this is easy for me because the distance from start to finish, I start at 0 and I finish at 2 pi over 3. So starting at 0 is like starting at the starting line, and you run 2 pi over 3. So your distance is 2 pi over 3. So we're going to take that total distance and I'm going to cut it up into 4 equal pieces. So the reason that I'm doing 4 pieces is because if you look at your graph, here's 1, here's 2, here's 3, here's 4. So we're going to cut it up into 4 equal pieces. All right, so let's do that. So remember, keep, change, flip. So we're going to keep the first fraction as it is. So 2 pi over 3. And then we're going to change the division to multiplication. And then we are going to change the 4. We're going to flip it, and it's going to become a 1 over 4. All right, and so when we multiply, 2 pi times 1 is 2 pi, and 3 times 4 is 12. And then we're going to reduce, and that's going to give me pi over 6. All right, and so pi over 6 is going to be your spacing on the tick marks, and we're just going to count it, okay? So this first one is going to be pi over 6, and then we're going to add a pi over 6, so that's going to be 2 pi over 6. The next one's going to be 3 pi over 6. We're just counting, adding 1 each time. The last one is going to be 4 pi over 6. Now, the only reason I did the last one is just sort of a check. I want to be sure that 4 pi over 6 actually reduces to this, and if it doesn't, then I know that I made a mistake. But 4 over 6 is the same thing as 2 over 3, so I'm going to go ahead and erase that. And then I would want to simplify anything that I can simplify. So on my fractions here, 2 over 6, that would reduce to 1 over 3. And 3 pi over 6, we could reduce that to pi over 2. All right, and then we're ready to draw our graph, okay? So we've now changed the period, we've got our new tick marks on the graph, and we'll sketch out our sine function. So we're going to remember that we have a x-intercept at first, third, and fifth. We have no other changes in the graph. So above the second point, you're going to be up at 1. And above the fourth point, you're going to be down at -1. And then we'll just construct a graph to connect those dots. And we have our new graph for sine 3x. Okay, so I'm going to stop there for just a second, let you kind of catch up. I'm going to do a different presentation. We're going to put some of these ideas together, and then we're going to also look at the cosine function.